Hello friends, everyone, welcome back. So, today we will be studying about units of temperature. Units of temperature. There are two types of units of temperature. First is common unit and the another one is SI unit, or we can say standard unit of temperature. Why in common unit we say degree Celsius and in SI unit we use Kelvin. Why we are saying common for degree Celsius? Because it is being used in our daily lives and by most of the people. So this is a common unit, and for scientific purposes and scientific work, the degree which is being used, the unit of temperature which is being used is Kelvin. Hence this has been given the name as SI unit. Now we will be studying about both of these one by one in detail. Let's start from Celsius. Celsius unit. Celsius unit is denoted by capital letter C, and before that we put a degree sign. So if it is written C is written with a degree sign, it means degree Celsius is. The clinical thermometer which we use for measuring human body temperature in our daily lives when we have fever is also based on Celsius scale. Now on Celsius scale, most of you might be knowing the melting point of ice. On Celsius scale, the melting point of ice is 0 degree Celsius and the boiling point of water on Celsius scale is 100 degree Celsius. Only this much we have in degree Celsius. Now let us move to another unit, that is Kelvin, which is also the SI unit. Why this is known as the SI unit? Because it is being used by most of the scientists and in research purposes. That is why this unit of temperature has been given the name SI unit. For Kelvin we denote it by the letter K, and one very important thing that you all must remember here is that we do not put a degree sign with K. We never put this degree sign with K. Kelvin is denoted only by the capital alphabet K. This is the standard unit, and the melting point of ice on Kelvin scale is 273 Kelvin, and the boiling point of water on Kelvin scale is 373 Kelvin. I hope most of you might be knowing this. Now let's move further. See, when we were talking about Celsius scale, what I told you, the melting point of ice is 0 degree Celsius. But when we were doing about Kelvin, what I told you, the melting point of ice is 273 Kelvin. So the melting point is same. So what it means? It means that 0 degree Celsius is equals to 273 Kelvin. Sorry, really sorry, it's 273 here. It's not 237, it's 273 here. So what do we conclude? That 0 degree Celsius is equals to 273 Kelvin. This is clear? Now why it is like this? Because melting point of ice on degree Celsius scale is 0 degree Celsius, and the same melting point of ice on Kelvin scale is 273 Kelvin. So melting point is same. So what we concluded from here is that 0 degree Celsius is equals to 273 Kelvin. Now since 0 degree Celsius is equals to 273 Kelvin, it means what? That the temperature on Kelvin scale will be equal to the temperature on Celsius scale plus 273. Means, see, if you add 0 degree Celsius plus 273, so what you will get? The temperature on Kelvin scale 273 Kelvin. So what we can say, that the temperature on Kelvin scale is equals to the temperature on Celsius scale plus 273. So it means whatever will be the temperature on Celsius scale, in that you need to add 273, just you need to add it simply, so then you will get the temperature on the Kelvin scale. Let me make it more clear to you by doing one sample question. See, suppose you have 25 degrees Celsius. This temperature is on Celsius scale. Now you need to convert it into Kelvin. So what you will do is you will just simply add, since I have told you that 0 degree Celsius is equals to 273 Kelvin. So 0 degree Celsius plus 273 degree Celsius is equals to 273 Kelvin. Sorry, 273 is equals to 273 Kelvin. So what you will be doing here, you will be just adding 273 to 25, and then you will get the answer as 298 Kelvin. This is what you have to do. This is very simple. I hope most of you must be understanding it. So from this discussion, what can we conclude? We can conclude that to convert a temperature on the Celsius scale, if we have to convert it from degree Celsius to Kelvin, you have to add 273, and the opposite is also true. If you have to go from Kelvin to degree Celsius, then what you have to do? You have to subtract 273. This is very simple and basic. For going from degree Celsius to Kelvin, you need to add 273, and for going from Kelvin to degree Celsius, you need to subtract 273. Now, moving further, let's go to another topic, that is change of state of matter. We have already discussed what is matter and what are its different states. These are solid, liquid and gas. Now here we will be studying how these different states of matter are inconvertible from one state to another. That is how solid can be converted into liquid and liquid can be converted to gas, and vice versa, how gas can be converted to liquid and liquid can be converted to solid. So basically, when we are changing the state of matter, it can only be done by two processes. The state of matter can be changed only by two processes. First is by applying temperature and second is by pressure. So either we can increase the temperature or we can decrease it. Similarly, it's with pressure, either we can increase the pressure or we can decrease it. Now what temperature and pressure have their different effects, I will be telling you. Let's first talk about temperature, then we will be going to pressure. When we are increasing the pressure, this is our first case. When the temperature is increasing, what is happening? Solid is getting converted into liquid. Why? Because when increasing temperature means giving heat. So when heat is being given, what will happen? The particles which were present in the solid, they were very tightly packed. They did not have spaces between them. Now what will happen? When heat will be given to them, the particles will try to move apart. So when they will try this, what will happen? There will be spaces left between these particles and these will become less closely packed. So in this way, solid will get converted to liquid, and similarly, if we will further increase the temperature, what will happen? These particles will move very far apart, more far apart they will move. Now what will happen? More space is being created between the particles. So now this will be converted into gas. So this is the procedure how solid is converted into liquid, and applying further heat or increasing further temperature, the liquid is converted into gas. Now let's take opposite of this, and when we are decreasing the temperature, what will happen? This initially, now it was a gas. When we are decreasing the temperature, the kinetic energy with which this, or the speed with which these particles were moving, it will slow down because we have stopped giving heat. Now when they will slow down, the energy will be slowed down. So what will happen? The particles will come close to each other. So when they are coming close to each other, there will be less space left between the particles. So what is happening? It is getting converted into liquid, and further, when we are not giving energy, the speed with which the particles were moving will slow down. Now it will change into solid, and they will come very close to each other. So this was the effect of pressure on changing the state of matter. Let's see once again. When we are increasing the temperature, first the particles are moving far apart, so it is solid is changing into liquid, and further when we are supplying more energy, it is changing into gas. And when we are decreasing the temperature, now if it has become gas, what will happen? When we are not giving temperature, they will come close to each other, the particles will come close to each other, so it will be changed to liquid, and then it will become solid. So this is the effect of temperature on different states of matter. I hope this is clear. Now moving on to the pressure. See, suppose you have a gas in a container, and we already know that the particles of gas are very far apart from each other, and there is so much space left between the particles. This is the space which is being left between the particles. So now what will happen? When we will apply pressure from the top, we are applying pressure. So this was the container, now pressure is being applied. So what will happen? This will compress, and after compressing, what will happen? The particles will come close to each other. So when they are coming close to each other, this is the structure of the state, which is state liquid. And when further pressure we are applying over here, what will happen? The particles will come they will come more close towards each other. So now what will happen? It will further change to solid. So on increasing pressure, the gas is changing first to liquid and then to solid. On increasing the temperature, the reverse was true, but on increasing the pressure, it is vice versa. Let me explain you one more time so that it is easier for you to understand. What will happen? Suppose you have a gas in a container and you are applying the pressure. So due to the pressure applied, what will happen? The particles will come more closely towards each other, and this is the structure of the liquid. So the gas will be converted into liquid, and on applying further pressure, what will happen is that the particles will come more close to each other, and they will occupy more spaces, and less intercellular spaces will be left, so it will be changed into solid. So this way gas is being converted into solid on increasing pressure. Now let's decrease the pressure. On decreasing pressure, what will happen? If this was the container, and initially you have some pressure on a gas, this is a solid now, and you are decreasing the pressure. Now since the upper pressure is decreasing, so particles will move far apart from each other, and when they are moving far apart from each other, they will take the shape of the liquid, and further decreasing the pressure, they will be free to occupy whole of the container, so that the more space is being left. Now they will occupy the structure of a gas. So in this way, solid is being converted into gas on decreasing pressure. So matter can be changed into different states on the basis of two processes, that is first temperature and second is pressure. On increasing the temperature, solid is being converted to gas. On decreasing temperature, gas is being converted into solid. On increasing pressure, gas is being converted into solid, and on decreasing pressure, solid is being converted into gas. So this is what we have to study here. Now let's see what this effect of change of temperature have. Effect of change of temperature. What are these processes called? When we are converting a solid into a liquid, then we are converting liquid into a gas. So what are these processes called? We will be studying this here. Okay. Now first is we have to convert solid into liquid. Now when you take ice, it is solid, and after some time it changes to water, means it is becoming liquid. So what is this process known as? This is known as melting of ice. So converting of a solid into a liquid, this change of state of matter is called melting. Changing of solid into liquid is called melting. The temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called the melting point of the substance. For example, the melting point of ice is 0 degrees Celsius. Because at 0 degrees Celsius it is being converted into water. And one more thing you all should remember here is that higher will be the melting point of solid substance, greater will be the force of attraction between its particles. See how? Suppose if there is a substance A and there is another substance B and another C substance, it's there. It has a melting point of 0 degrees Celsius. The another one has say 100 degrees Celsius, and the another is having 1500 degrees Celsius. So here the temperature is less, here more temperature is required to change it into liquid, and in the third case very large amount of heat is required to change it into liquid. So since very large amount of heat is being required, so what is happening? The particles must be more tightly packed, that is why we are supplying more energy. So it means the force of attraction here in the third case is more strong as compared to this one and this one. So what can be concluded? That higher the melting point of a solid substance, as in this case, as in the C example, greater will be the force of attraction between its particles. Now when we are heating a solid sufficiently so that it is being converted into a liquid and its physical state is changing, this is the process which is known by the scientific term called melting. So this was a first process. Now moving on to the second process, that is changing of a liquid to gas. Here what is happening? Liquid is being changing into gas. This is done by the process called boiling, either we can say, or we can say vaporization. When you take water in a container and you are heating it, what will happen? After some time steam will be formed, and this steam is in which state? It is in gaseous state. So here what you are doing, you are converting water which was initially in liquid state to steam which is now at gaseous state. You are converting the state of matter, and this changing of state of matter is known by scientific term called either boiling or vaporization. Now the boiling point of water is 100 degrees Celsius. Why? Because when we are applying heat energy of 100 degrees Celsius, then water is being converted into steam which is in gaseous form. Now one more thing that you all should remember here is that different liquids have different boiling points. For example of water, I have already told you it is 100 degrees Celsius. Another example is like of alcohol you can take. The boiling point of alcohol is 78 8 degree Celsius. So different liquids have different boiling points. It is not that if you take water, alcohol, milk, juice, all will have same boiling point. Different liquids will boil at a different temperature. More the boiling point, more the particles are closely packed. See, now suppose in water you are giving heat energy of 100 degrees Celsius, and in alcohol you are giving the heat energy of 78 degrees Celsius. So in water more heat energy is being given to change into gaseous state than alcohol. So it means what? The particles of water are more closely packed as compared to those of alcohol. So what is boiling point? It is clear. The temperature at which a liquid boils and it is changing into its gaseous form at atmospheric pressure. You are not applying any external pressure. At atmospheric pressure it is changing. This is called the boiling point of the liquid. So when a liquid is heated, its physical state of matter is changing and it is becoming gas, and this is done by the scientific process called either boiling, or you can call it by vaporization. So this was a second also done. Now moving on to the third. What we have to do? We have seen that we have converted solid into liquid by the process called melting. Then we have changed liquid into gas by the process called boiling. Now what we have to do? We have to reverse the process and we have to change the gas into liquid, and then further we will change liquid into solid. Now what we will do? We will change the gas into liquid. Most of you have observed that when you boil water in a container and then you put some cover on it, after some time when you are boiling, the gas is there, steam is there, and when you are covering with a lid or something, water is accommodated here on the inner side of the lid. This is why, because the steam which was there, it is being converted into the liquid form, and this is done by the scientific process which is known as condensation of liquid. What is happening? If in a container you are having some gas or steam and you are covering it up, then after some time what you will see is the liquid droplets of water on the inner side of the lid. This is because the gas has been converted and it has cooled and condensed to form the liquid. So this is known as condensation. So now I hope you all can write the definition of condensation. It is the process of changing of a gas into a liquid by cooling, and this is known as condensation. It is nothing but just reverse of what you were doing in changing in liquid to gas. It's the reverse of vaporization. In vaporization, what you were doing? You were converting liquid to gas. Now here what you are doing? You are converting gas into liquid. So it's just the reverse of vaporization or boiling. So this was a third conversion. Now moving further. Now fourth is what you have to do. Now here you will convert liquid into solid. All of us, what we do in summers, we keep water in a container and we keep it in the refrigerator so that it becomes ice. So what is happening here? Liquid is being changed into ice, or water is being changed into ice. So state of matter that is being changed is liquid is being changed into solid. So this is the only process which is known as freezing. You are freezing water so that ice is being formed. So liquid is being changed into solid. You can also say it solidification. Why? Because the solid is being formed. So you can also say solidification. Freezing point of water. what is the freezing point of water? It is 0 degree Celsius. Here also the state is being changed from liquid to solid. So this is known as freezing. It's the reverse which we have done when we have converted solid into liquid. Here what we did, we have melted. So freezing is just the reverse of melting. So I hope now it's clear that how temperature has its effect on changing the states of matter. Just by increasing the temperature or by decreasing it, you can change the states of matter and you can convert it from solid to liquid or from liquid to gas, and vice versa is also true. So let me give you the quick summary of this. Solid, here we write liquid and here I am writing gas. When we are heating it, it is becoming liquid, and when I am heating further, it is becoming gas, and when I am cooling it, gas is converting into liquid, and when I am further cooling it, liquid is being converted into solid. So now I hope this is clear. So in this video we will be continuing till here only. In the next lecture I will be telling you about latent heat of vaporization, and then we will be going further. So I hope you all must have understood it and liked it. Then please hit like button, share it and subscribe it. Thank you.